This part of the session today is about ground truthing. I guess first of all, it'd be good to make sure everyone has a clear idea of what we're talking about when we say ground truthing. Ground truthing, ground validation, they both mean the same thing in the context that we've been using it. And really it's to confirm or validate directly. So validating information that we've collected indirectly, such as satellite imagery, using direct observations on the ground rather than interpreting remotely obtained data. Now obviously, Gwar mentioned yesterday, there's caveats around that. So there's a lot to be said for using very high resolution remote sensing imagery, such as from drones, to help ground truth, sort of low res imagery, such as sentinel data. So last few weeks for the ground South Georgia stuff particularly, I've been sitting down with Sally. We've been looking at some of the drone imagery that we collected on the expedition earlier this year. And yeah, the resolution is so good that it's almost like you are there looking at that landscape in front of you and you can pick out the different habitat types. And obviously that's where Sally's expertise with her knowledge of South Georgia habitats comes in. She can look at it and go, yep, I've been there, that's that, that's that, that's that. So that's an interesting thing that we're going to be looking at, hopefully within the project, as in the cost-benefit analysis of using drone imagery to validate versus someone out walking with their GPS and collecting ground validation data themselves.
Can I just ask a quick question on that one? If I want to map something as obvious as stone ones or so, and I can make them out in Google Earth images, do I actually need to go out there and have a look?
I'd say probably not, because I think Gwar may correct me, but I would say if you're using Google Earth imagery and you can clearly see the stone runs, and they are a massive feature.
Well, the problem with that is that if you're creating a map of the whole area, so stone runs is only one small component of your whole map, then you will need
other data
to validate that that is actually stone runs in the context of the map. But you can just use Google Earth and create points on Google Earth. You don't have to actually visit there if you can tell by those imagery. This is one of the uses of drone data for me, is doing the ground truthing, because the drone data has so much detail in it that you can infer what's there on the ground from the imagery itself, where you can't do that with some of the satellite data. So there's other ways of collecting ground truthing data beyond visiting in the field, essentially.
So I said, why is ground truthing important? Well, we need ground truthing to train the models that Bran's just talked about. So when you have a particular spectral signature from your satellite imagery, you need to know what that is in reality, and that's where the ground truthing comes in. You can either go and visit the site or use other information to help you validate that. Maybe this is coming on to a bit later that Bran's going to cover, but as well as using the ground truthing data to train your models, so to train your habitat models to predict particular habitat classes, you also retain a proportion of your ground truthing data to validate afterwards. So your model's gone off and predicted a particular suite of habitats across the area. You then feed in your data that you've held back to actually validate, and you can create error matrices, and I think that's coming later on. So obviously for the projects, developing a standardized way that we were collecting this information is very important. So I've mentioned the app that was created by the IMS Data Center, so Ilarium and PB, who's just arrived. That was one way, to speed up the process, because it can be quite labor intensive and laborious going around filling out paper forms, and then you have to go back to the office and enter all the data into a spreadsheet, then it gets sucked into the model. So to try and speed up that process, and also just have a think that that's the process where errors start to creep in. So the transcription errors by writing stuff down, putting it onto a spreadsheet, things can creep in. So to try and minimize the risk of those errors happening, if you can automate it and make it as less human interactive as possible, as in whenever humans input stuff, that's where errors will creep in typically. So if you can minimize as much of that as possible, then actually that's a good thing from a modeling perspective. Important aspects to consider. So we've talked yesterday about seasonality. So think about when you're doing your ground truthing, are you ground truthing at the same time that the imagery was collected? So it's no point going out to ground truth an area in winter in South Georgia when it's snow covered, when actually the imagery was collected in summer, and vice versa. So on our expedition to South Georgia, we got to KEP, and we were, first of all, there was very windy for the first day, so we couldn't fly any drones when there was no snow, and then the day after there was about 3 inches of snow, so you couldn't actually see the ground either. So yeah, you need to think about those things and just make sure where possible you want to be collecting your ground validation data, your ground truthing data at the same time or the same season that your imagery was collected. We've got a lot about sensor resolution, so as in how do you validate or ground truth a 30-meter data set such as Landsat versus a Sentinel at 10 meters and Worldview at 2 and drone at sort of centimeter level. And that'll become really apparent this afternoon when we get out in the field and actually have a go at collecting ground truthing data. And the other thing to think about is GPS errors. And I'll come on to that in a bit more detail later on. So we touched a bit just now on the discussion about different ground truthing sources. Obviously field observation is probably the best, but also probably the most labour intensive. Going out in the field, actually seeing with your own eyes what's there, understanding what the sensor is seeing, how big a pixel that sensor is recording, and actually how that size of sensor pixel relates to what you think it's going to be seeing, as in we saw how big a 30-meter square is out in the field, and what you see as that single value in that 30 meters is going to be very different to what you see in the 10-meter squares or meter squares from the Worldview imagery. So yeah, thinking about the that sensor size. High resolution aerial imagery. So we just talked about drone imagery and how we can use that to validate coarser level information such as Sentinel imagery. In situ spectral measurements. This is probably something Guan knows more about. We haven't done this within the project, but I guess when you're looking at different spectra, you can actually measure instant light at a particular point and use that to validate your maps in that way. Even looking at maps and charts, if you're looking at a map and a chart and you can tell what's in the sea and what's land, that in a way is a form of ground truthing. And I guess when Brian went through the modelling process, we had to distinguish between what was land and what was sea. So you created probably a set of points for the sea based on looking at Google Earth or something like that. You can look at descriptive reports and also just discussion with experts. So people who are familiar with the habitats, and I guess this is where Sally comes in from a South Georgia perspective, speaking to the people, sitting down with them, and just looking at the data and I guess understanding the spread of the habitats and actually what's where. And that's really invaluable and yeah, very useful. So I guess really within this project, within the Coastal Habitat Mapping project, we've focused on sort of field observations, high resolution aerial imagery, and the sort of discussions with experts as the 3 key forms of ground truthing for the project. We talked a bit about resolution. This is I guess a 3D view of Coppin Point in South Georgia. But you can see the range or the sizes, patch sizes of data of habitats that we're dealing with. You've got the foreshore, sort of 15 meters in width. So that's going to fall within, in theory, 1 pixel size for your Sentinel imagery. But that's only going to be half of your Landsat image. And obviously, from a Worldview, there's going to be multiple pixels within that. Right through to your band of tussock at 35 meters. And then, I guess, the introduced grasses here, this band here, which is about 20 meters. So getting out and looking at, the different patch sizes you have at your disposal and how you're going to ground truth those is quite important. And then you start to think about, well, where do I want to collect my points, your ground truthing points? And there's various schools of thought. Statistically, you can randomly assign a set of points to particular areas. I guess the downside there is some of those points may fall on the boundaries. And really, a lot of the time, you actually want to make sure that you are fully within the pixel that you're trying to ground truth. So always bear that in mind. Another question that we get asked a lot is, how many points do I need to collect? And I guess the simple answer is probably as many as possible. And I guess a lot of that will come down to the project budgets, the time you have available, and the funds. Where possible, try and make sure you collect the same number of points for each class. So rather than have 25 points for your tussock and actually only 4 points for a mossy habitat. Ideally, you want to have a standardised number. That will be, I guess, fairly challenging when you look at how abundant different habitat classes are. You may struggle to find 20 points from mossy habitat. But I think where possible, do try and do that.
Is there a minimum number?
I'll hand over to Bran.
If it's a distinctive class, it's basically if you look at the imagery, it looks very different from its surroundings. You have a better shot at being able to classify it with fewer points. If like the trouble you're having with different grasses that look more similar to one another, you need a lot more points for that to get different grass species than like moss versus a grass and just summary about it.
Rule of thumb is n equals 30 for most classifiers. And that's based on decades of people mapping things in a supervised way. So rule of thumb n equals 30, which, as Neil and Bran has alluded, is not possible in all cases.
Yeah.
But if you can get it, then that's great. So any more or any less in a standardised landscape wouldn't make a significant difference to the output of the classifier. So that's kind of the sort of levelling off number of points that you need for a classification output to be of a certain accuracy.
It's certainly, I think, the whole subject of ground truthing is quite a widely discussed and investigated subject about how many do I need statistically to demonstrate a difference in habitat type.
Yeah, and sorry, you might get onto it. Do they all have to be would they all be in a similar spot, or does if you took 10 in this area and then you do 10 somewhere else and your other 10?
Better if you would spread it out possibly. And it's also better if you, go to the transitions also. Don't just get in the center of the grass, but if you're transitioning into heath or something, get some of the transitions too.
Yeah.
So it knows how to deal with pixels that are a bit of both, mixed pixels.
Okay.
So there's sort of not like a rough guide as to how many you need for, say, an area of a hectare.
It depends on how many classes you have inside it.
Yeah.
How, if it's all one thing, you don't need as many answers.
Yeah, so it really is up to you to decide and figure it out.
And that's why you have to go back out a lot of times, that didn't work. We go back.
So one of the ways to do it is to run your imagery through an unsupervised classification technique, which does the opposite of this. So it tries to split up the landscape based on similar pixel values together, similar to creating segments like object-based image analysis. And it'll give you an output, and then you have to decide what class that output is. So an unsupervised classifier is the opposite. So you could use that to try and decide how many classes are within your hectare, and then within that again, how many points you need. So there's lots of ways of getting around that problem. I don't know, Bran, you probably might talk about this.
We do a little bit about supervising.
Yeah. And the only other thing is, I guess, we've talked about using multispectral data. So just remember that there may be things happening on the ground that you can't see with your own eyes. So we've talked about, the synthetic aperture radar from Sentinel-1 imagery, which looks at the roughness of the habitat. There's bands such as near infrared and red edge and all those other bands that you can't see with your eyes, but they may be telling you information about why that habitat is there and which habitats are where. So just bear that in mind, that just because you can't see a change necessarily, there's no reason not to collect ground truthing data because of that.
What is the equipment for that? Yeah. If you're going to do that in the field, what would you take?
For the ground truthing?
Yeah, if you wanted to use that.
And I'm saying that if we're inputting other data sets into our model, like near infrared, red edge, the other bands in the multispectral imagery, they're going to be driving to a certain extent how that data splits out into the different habitat types. So what I'm saying is, just because you can't visually see a difference on the ground is not a reason not to collect. Am I confusing people?
That's remote imagery you're talking about?
Yeah, so
you can actually take a photograph of at the time. You see what I mean? Like infrared cameras? You're not talking about using that?
No, I'm not.
Okay.
No.
Okay. So it's the satellite imagery.
The bottom line with the habitat model is we're effectively trying to predict where the habitats are from the remote sensing imagery. So it goes down back to the end use of what you're trying to do, what you're trying to map, and thinking about why is that tussock habitat growing there? What are the environmental parameters that are driving that system to be there? And that's why inputting data sets such as aspect and slope and rugosity and other things, other variables which can help you help. Yeah, exactly. It's using those data sets to help predict which habitats are where, and it's really that information which we need to consider, as well as that from a ground truthing perspective. I guess I'm just trying to don't just get fixated with finding a particular patch and taking a point. So Megan and Bran touched on where do you take your points, and this is where your accuracies or inaccuracies with GPS come into play as well. So if you imagine these are some 6 pixels from your sentinel imagery, so they're 10 meters across, and hypothetically these 3 are whitegrass, acid grassland, and these 3 are diddly dry shrub heath. So if you took your point at the edge of that 10 meter square, potentially, because your GPS is accurate to 3 meters, you could actually be inside this cell, or you could actually be inside this cell. So just think about when you're standing with your GPS, taking your point, what's around you. Gua mentioned yesterday about adjacent pixels, and the fact that you may be standing in an area of whitegrass, which is 10 meters across, but actually that pixel where the sensor is recording could be half in that whitegrass and half outside. So you could actually only have 5 meters of whitegrass, and then you're going to have a mixed pixel with a mixed values.
But there are ways of sort of ground truthing your GPS, say find quite a big rock, stand next to it and go, right, this is my GPS coordinate here.
Yeah, and you can use RTK GPS and much more accurate. But I'm thinking about if you're going out with a handheld, which does have an inherent inaccuracy with it. Just
you don't want to do that for every single GPS
No.
point you're collecting if you're collecting 30 per class.
No, I'm just sort of thinking the GPS accuracy would be the same if that's one GPS all the way through, or?
But it might not be.
It may vary.
How many satellites it's seeing at any point in time, so it could knock off a satellite and whatever, and then the accuracy changes. So it's not set in stone throughout the time of the recording.
Said there would be the same all the way through, but
No.
I would say that's unlikely. I would say that the GPS accuracy varies depending on where you are in the field and how many satellites you can see at any one point in time. It's not constant, so in theory that would be lovely if you could do that, but in reality it's not the case, I'm afraid.
So a prime example would be we collected some drone imagery at El Zahal, and up on the top of the scree slope there was a lot of acenas, so it's a herb field community. It was really distinctive on the drone imagery. It came up as like a teal colour, and when I was sitting down with Sally looking at some of the imagery, you can pick it up across all of those, almost those 8 areas that we looked at. So it's very distinctive. I went out the morning before we left with my GPS and the app, and I was going around collecting ground validation points, particularly for the habitat classes I saw on the drone imagery, which I wasn't sure exactly what they were, and I wasn't sure what this was. This was the first aerial survey we did of South Georgia using the drone. So I got up to the top of the ridge, and there was a nice moss bank, which is really clear on the drone, so I took a point in the middle of that. trotted along a bit, found these bands of Acina coming up the slope, took a point in the middle of that. Now these bands were, maybe 2 meters across, so they're quite small, but they're very distinctive in the drone imagery. Then when I got back onto the boat and plotted those GPS points on QGIS with the drone imagery, which was a georeferenced orthomosaic, the points fell outside by a metre or so. So if you'd fed that into your modelling process, you'd actually be validating the wrong habitat class. So I guess what I'm trying to say is just bear that in mind when you're taking your points, particularly when you are ground truthing very small, discrete features, particularly from the drone imagery. It's probably not so bad from a world view because you're thinking much bigger, but particularly from a drone perspective, it's worth bearing that in mind. And also go back and check when you collect your points, where do they actually fall? Because with your point, you'll have with the app, you'll have a photo saying what habitat you were recording at the time. If it doesn't tally with where it's falling on your drone imagery, then you know something's gone awry somewhere. So. Yeah, and consider patch size basically. And this will be hopefully become more clearer this afternoon when we get out in the field and actually put this into practice. I think Brian said this before, but consider what your end goal is and what you're mapping. And we talked a bit about other contextual information that you might want to think about recording at the same time. So when we've been out in the field collecting data for the project, we've been looking at aspect. So a north-facing slope may have a different plant community to a south-facing slope. How big the patch size is, that's really useful. And when you get back to look at the data back in the office, to know was this person looking at a 100-metre patch size, so a huge area, or actually a very discrete area, and that may obviously influence then how much confidence you place on that particular point. Looking at the geomorphology, so whether the environment you're in is collecting or shedding. So is it in a big bowl and collecting water and could potentially be very damp and very wet, very boggy, or actually is it shedding water? So is it going to be drier? And obviously that would then influence the plant communities and the other environmental communities that you see at that point. Always, if you can, just jot a quick description down. That's really useful to the person, if it's not you, back in the office actually looking at that data. And I think Brand's found that particularly useful, probably looking at some of the ground truthing data that's come back through the project. And obviously you can't really replace having photos. So within the app we're going to use, you can take a photo down at your feet, looking straight down, and then take a photo looking north, east, south and west. And that really puts that point into context of the surrounding habitat. And has been very useful, particularly when going through stuff with Sally. And the last thing is record mosaics as well. So life is never very simple, and I think habitats aren't very simple. So it's very rare that you will get a nice, neat patch of whitegrass, a very nice patch of diddle-dee. It's going to be, a lot of it's going to be mixed up. So mosaics of different habitats together. And obviously that influences the spectral signature that the satellite's going to be seeing or the drone's going to be seeing, and it's important that's captured. I think at the end of the day, someone who's actually processing the data probably needs to make a call, which may be Brian, about actually what class do you put that under. But at least the person who's doing the modelling understands that this isn't just a pure stand of whitegrass or diddle-dee, that it's a bit of a mixture, and that can then be taken account when you're doing the habitat modelling. And we touched on the recording forms. Before we go out this afternoon, I'll show you the paper forms that we've been using, and also we'll go through in the field a quick demo with the electronic recording forms. But I think, from my perspective, I guess it's useful having the paper as backup, but you can't really underestimate the importance of getting the data in quickly as possible when you're standing freezing cold outside, and then getting it going back to the office, just submitting the forms onto the server. They go into a database, and then you can plot them straight away in QGIS. It's really quick and really eliminates a lot of the errors. So, and I think PB is going to allude to that in his talk. There we go. Any questions on the ground truthing stuff?
Where did the classifications come from in the first place? Are they established already? Are they?
Yeah, so the Falklands classification we based
Probably based on
Rebecca Upson's report, yeah. So Rebecca developed a Falklands scale hierarchical habitat classification. So we'll use the upper levels for the broad scale maps where possible, and then we went down to the finer scale. She had sort of level 1, level 2, level 3 and level 4. So we use the lower levels for the more fine scale maps, so from Worldview and drones. And for South Georgia, we used a lot of work that Jenny Scott and Sally did in the 2002-2003 baseline stuff.
I have to say, for some projects, though, particularly the restoration type projects here, there aren't adequate categories to sort of capture the change yet. So have to think about, it'd be good to think about what kind of extra categories would be capturable.
Yeah, and something that I would recommend just when you're going out and you're figuring out what classes you're going to record in your ground truthing is leave enough detail in what you're recording that you can go back later and capture some classes that you think are important later on. So if you're only mapping all grasses right now, if you can map like the specific species that you think in 2 years you might be interested in mapping, it's worth it to spend the extra time now and record that level of detail because you can't go back and go more specific afterwards. You can go more general, but not specific. So when you have to make a choice, go more specific to help with that.
And I guess a lot of the points that we fed into the Falklands broad scale maps were the ones that Ilara collected. So she did some work for the Natural Capital Project. So a lot of that stuff we've integrated into and used that as well as supplementing with other information too. So that's been really, really useful, really valuable. I guess collect once and use many times. That's the motto. And if you can collect information at a sufficient resolution that can be used multiple times, then that's obviously better than going back out and collecting the same type of information again and again and again.